Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like 4+1 view model, various workflows. Let's get started. Slide 1, 4+1 view model, introduction and definition. Let's begin by understanding what the 4+1 view model is. It is an architectural model used to represent the design of complex software systems from multiple perspectives. This model was introduced by Philippe Cruchton as part of the Rational Unified Process group. The core idea of this model is to break down a complex software system into manageable views, each focusing on specific aspects of the system. These views help in simplifying complexity and improving communication among different stakeholders like developers, designers, and clients. Instead of looking at a system as one big entity, the 4+1 view model encourages us to understand its parts, how components interact, how the system runs, how it will be deployed, and how users interact with it. The four main views are logical view, process view, development view, and physical view, and the +1 represents the scenarios or use case view that ties all the other views together by demonstrating real-life functionality. For example, in an online banking system, the logical view will describe classes like customer and account. The process view will show transaction processing steps. The development view will indicate which module holds which code, and the physical view will describe where servers and databases are deployed. Slide 2. Components of 4+1 view model. Now, let's explore each of the views in the 4+1 view model. 1. Logical view focuses on what the system should do, and how its parts work together logically. This includes UML diagrams like class diagrams. For instance, in a hospital system, a class diagram might show patient, doctor, and appointment classes and their relationships. 2. Process view describes how the system behaves when running, the system's processes and how they communicate. This is critical for understanding concurrency and parallelism. For example, how a payment process interacts with a stock management system. 3. Development view, sometimes called implementation view, shows how the system is organized in terms of modules and packages, in simple terms, how the codebase is structured. For example, separating user interface code from business logic code in an application. 4. Physical view, also called deployment view, shows how the software will be installed and deployed on hardware. It explains where each part of the software runs, like the database on one server and web application on another. 5. The use case view, scenarios, is essential as it validates all these other views. It shows how real users will interact with the system, ensuring that the system actually supports real-world functionality. For instance, how a user logs in, searches for products, and makes a purchase in an e-commerce system. By combining these views, the 4+1 view model makes sure that all aspects of system design are considered and aligned. Slide 3. Various workflows in object-oriented software engineering (OOSE). Next, let's move on to workflows in object-oriented software engineering (OOSE). Workflows are essentially structured activities or steps that guide the software development process. 1. Business modeling workflow helps us understand the business context. For example, if we are developing software for a hospital, this workflow defines how patients are admitted, treated, and discharged. 2. Requirements workflow is where we capture and analyze what the software needs to do. This includes both functional, e.g., user login, and non-functional, e.g., security, requirements. 3. Analysis and design workflow transforms the requirements into a technical blueprint. Here, we use class diagrams, sequence diagrams, etc., to design the system. For instance, designing how a payment gateway interacts with a shopping cart. 4. Implementation workflow is where we write the actual code, based on the design created earlier. 5. Testing workflow ensures that the system works as expected. It includes unit testing, integration testing, and system testing. For example, testing whether a payment gets processed correctly. 6. Deployment workflow focuses on delivering the final product to the end users, such as deploying a website on a cloud server. 7. Configuration and change management deals with version control and managing changes in the system, using tools like Git. 8. Project management workflow involves planning, tracking, and managing the entire project to ensure it meets deadlines and goals. 9. Environment workflow sets up the necessary tools, platforms, and environments needed to develop and test the software, like installing IDEs, servers, and databases. These workflows help ensure a systematic and organized approach to developing high-quality software. Slide 4. Advantages and disadvantages of 4+1 view model. Finally, let's discuss some advantages and disadvantages of the 4+1 view model. Advantages. 1. Improves system understanding by providing different views that focus on specific system aspects, making it easier for all stakeholders. 2. Promotes reusability as it identifies components and modules that can be reused in other projects. 3. Supports parallel development, meaning different teams can work on different views at the same time, speeding up development. 4. Enhances communication because visual diagrams help in clear communication of ideas and design decisions. 5. Helps identify risks early, especially through process and deployment views, where concurrency issues or deployment challenges are visible. 6. Ensures scalability by allowing designers to visualize how the system will grow and handle increased load. 7. Facilitates design validation by using use case view to test whether the design supports required functionality. 8. Aids in easier maintenance because well-defined views help developers understand and update the system later. 9. Improves quality since different views reduce the chances of missing important system aspects. Disadvantages. 1. Complex for small systems, making it unnecessary overhead for small projects. 2. Time-consuming as it requires creating and maintaining detailed views. 3. Needs skilled personnel who understand architectural design and UML diagrams. 4. Tool dependency, as creating proper diagrams often requires specialized software. 5. Possible redundancy, since some information may overlap across views. 6. Higher initial cost because of effort spent in designing and documenting architecture. 7. Requires constant updating whenever changes occur in the system to keep all views aligned. 8. Risk of misalignment, where views might contradict each other if not managed carefully. 9. Less suitable for agile teams because heavy documentation may slow down rapid iteration cycles. So, while 4+1 view model is extremely powerful for large, complex systems, helping manage complexity and improving design quality, it might be less suitable for smaller or fast-changing projects due to its formal nature.